When your fuel pump seems to be working, but your engine isn't getting enough fuel, you're facing a common automotive issue that can affect any vehicle. Understanding why this happens requires knowing how modern fuel systems operate. Modern fuel injection systems require specific pressure ranges to function correctly. Port fuel injection systems typically need 30 to 80 psi, while direct injection systems operate at much higher pressures on the high pressure side, ranging from 500 to 2900 psi. Several factors can cause low fuel pressure despite a working pump. Let's examine the most common causes and their frequency of occurrence. The most frequent cause is a failing fuel pressure regulator, accounting for about 35% of cases. When the regulator sticks open, fuel pressure bypasses back to the tank instead of maintaining proper system pressure. A clogged fuel filter is the second most common cause, representing approximately 25% of low-pressure problems. This is often overlooked in modern vehicles with so-called lifetime filters. Other potential causes include restrictions in fuel lines from kinking or debris, faulty fuel rail connections, stuck open fuel injectors that create pressure loss, and mechanical issues within the fuel pump itself, such as worn impellers or internal components. Understanding these components and their interactions is crucial for proper diagnosis. Each element in the fuel system must work together to maintain the precise pressure needed for optimal engine performance. The key takeaway is that a working fuel pump doesn't guarantee proper fuel pressure. Multiple system components can cause pressure loss, making systematic diagnosis essential for identifying the root cause. Diagnosing low fuel pressure requires a systematic approach. We'll walk through the essential diagnostic steps, tools, and cost considerations to effectively identify and resolve the issue. Step 1. Start with basic verification. Check that the fuel pump is actually running by listening for its operation when the ignition is turned on. Also verify adequate fuel level and fuel quality in the tank. Step 2. Perform fuel pressure testing. Use a fuel pressure gauge connected to the test port to measure actual pressure. Compare your readings to the manufacturer's specifications, which typically range from 30 to 80 psi for port fuel injection systems. Step 3. Test individual components. Check the fuel pressure regulator for proper operation, inspect the fuel filter for clogs or restrictions, and examine fuel lines for kinks, collapses, or blockages that could impede fuel flow. Modern diagnostic tools can significantly improve accuracy. Digital fuel pressure testers provide precise readings with data logging capabilities. Ultrasonic fuel system analyzers can detect internal component issues without disassembly. Understanding repair costs helps with decision-making. Fuel pressure regulator replacement typically costs $180 to $450. Fuel filter replacement ranges from $120 to $280. Complete fuel pump replacement is the most expensive at $400 to $1,200. Prevention is always better than repair. Regular maintenance, including timely fuel filter replacements, using quality fuel from reputable sources, and periodic fuel system cleaning can help prevent these costly issues from occurring in the first place. Remember, systematic diagnosis saves time and money. Start with basic verification, use proper testing equipment, and don't skip the simple checks. When in doubt, consult manufacturer specifications and consider professional diagnostic services for complex systems.